Greetings and welcome to the 9th technical webinar in the EUROCONTROL Stakeholder Forum series. Today, we will be discussing the impact of innovative technologies and sustainability of cargo operations. We will explore new generation technologies and see how they will make cargo operations more efficient, more sustainable, while maintaining the highest levels of safety. In essence, we will be hearing about how technology will shape the future of cargo operations, whether the air cargo market is ripe for technological disruption, the benefits of hydrogen and hybrid-powered aircraft, whether manned or unmanned, conventional taking off or vertically taking off machines, and most importantly, how innovative organizations are going to work together to promote safe, efficient, and sustainable cargo operation. And you, the audience, will be able to send questions using the Q&A session. If you encounter any technical issue or for any other regional general remark, please use the chat function. My name is Philippe Jopard and I will be your moderator today. Our panelists are Hugh Flynn, the Board Director of ASL Aviation Holdings, Mr. Rod Williams, Chief Commercial Officer of Universal Hydrogen, and Mr. Brian Wood, Global Head of Sales and Marketing at Pipistrel Aircraft. Hugh Flynn has over 30 years of experience as a senior aviation business leader. The board director of ASL Aviation Holdings and chairman of its subsidiary airlines, Hugh is also a board director of the Irish Historic Flight Foundation, chairman of Formidian Aviation Ireland. As a group chief executive of the ASL Group from 2005 until July 2020, Hugh has led a number of major growth transactions, including airline acquisitions. Rod Williams has served in a variety of high-level roles at Bombardier, including Vice President of Marketing and Vice President of Regional Programs. He also served as a Chief Marketing Officer of Wheels Up, as well as the President of its Canadian subsidiary. And finally, Brian Wood oversees the worldwide sales and marketing, including OEM and aftermarket sales. Brian is responsible for Pipistrel's cargo transport aircraft sales, surveyors, and engineering services, as well as propulsion components. Prior to this, Brian founded and ran the Hybrid Electric and Electric Propulsion Group at Honeywell Aerospace. At this point in time, I am delighted to invite Hugh Flynn to take the floor. Hugh.
Very good afternoon, everyone, and thank you, Philippe. So if we could just pull up the slide, I just want to give a little bit of a background on the ASL Group, just at a glance. There it comes. So to start with, it's important to say the ASL Group is a very short sentence, but it has involved an evolution of companies like Safet, Aeropostal, which is now ASL France, Hunting Cargo Airline, Farne, etc., which, I mean, some of them are 50 years or more older. So they've been in aviation. We've been in aviation a very long time. If we look there at the fleet, it's quite interesting, plus minus 140 airplanes, 13 different types. But essentially, it really runs from the 747-400 freighters through the Airbus A330s, the Airbus A300s, 757s, and then a range of 737s, which is really the focal point of ASL's operation, particularly in Europe, where we see the 737-300 QCs, the 400s, 700s, and more latterly, the 800 freighters, which we're going to talk a bit about later. And then, not in declining size, but more in importance, the ATR 42s and 72 freighters. Notably, we were the first in Europe to operate the ATR freighter. So it's something we're very proud of. And then also talking about turboprops going back many, many years, the Hercules aircraft, which we still have a few, although they're busy exiting the fleet. They played a major role both in Europe and then throughout Africa in terms of operations. If we look at the team members and nationalities, In Europe, we have 5 different airlines, one in the UK, Ireland, Hungary, France, and Belgium. And then we have 3 associated airline operations, one in South Africa, one in Thailand, and one in India. The global operations, if we look at global operations, North America, scheduled 757 passenger operations for several years. We ran across the Atlantic to the east coast of the US and Canada. The 737-700s from France, our French operation, with scheduled flights across to the French territorial island of Saint-Pierre-Miquelon. And then in history, we did a lot of flying with Hercules aircraft in the winter, in the Canadian winter in the Arctic, which took a lot of learning, a lot of challenges, but it makes you grow up quicker. We look at Europe very simplistically, but again, as I say, the focal point, we operate for and on behalf of the world's leading express cargo integrators all over Europe, many, many flights a day. Turning to Africa and SAF Air, apart from the Hercules I've mentioned, but very successfully, the Fly SAF Air low-cost airline passenger operation, it's been outstanding for the last few years, a global leader, best in class for low-cost carrier awards. And then Antarctica, again, we circle back to the Hercules a little bit in history, but we used to fly from Chile and also New Zealand to various points in Antarctica for various governments and customers alike. So if we just turn to the next slide, which is really to do with an initiative, an environmental initiative, which has arisen out of our ESG commitment, ASL's commitment to ESG. ASL Cargo Vision for Greener Sustainable Aviation was formed late last year in 2020, together with new aviation technology companies such as the guys that are around the table today and others listed on the screen, as you can see. The objective really is to raise and promote awareness of ASL's and the forum's innovation companies' initiatives in new technology and sustainability, particularly in the air cargo operation world. We're doing things, as you'll hear as we go through when Rod and Brian talk, we're doing things. We're not talking about it. Yes, of course we do talk, but you'll hear more about what we're getting stuck into in terms of the future of sustainable aviation in cargo. So yeah, as I say, on the webinar today, we've previously had Vertigo and Flylogix participate, and look forward to hearing from Brian and Rod, respectively, on Pipistrel and Universal Hydrogen. So thank you very much, Philippe, just for that short introduction.
Thank you very much, Hugh. And yes, indeed, certainly an amazing and awesome initiative. We'll get back to Cargo Vision in a moment. It is my pleasure now to give the floor to Rod.
Thank you very much, Philippe and Hugh. Appreciate the introduction. And if I can just share my screen. Again, thank you very much, everyone. My name is Rod Williams with Universal Hydrogen. I will just give you a quick introduction to what it is that we are doing at Universal Hydrogen. And we are on a mission to change aviation in terms of its path to true net zero by 2050. And what you see in this first picture encompasses really everything that we're doing. We are, first of all, creating an STC conversion kit to convert aircraft in the regional turboprop market segment, so the Dash 8 family and the ATR family. We are developing a hydrogen fuel cell powertrain, which replaces the turboprop engine that typically would be flying these aircraft. So this is a retrofit. And the key aspect there is that our plan is to have these aircraft in service by 2025, so significantly accelerating the adoption of a true zero solution. And then the third thing that we are doing is we are developing the hydrogen fuel capsules and modules that you see being loaded in the back there. And those serve both as a lightweight fuel tank within the aircraft, as well as it solves the infrastructure problem for delivering hydrogen from wherever green hydrogen is produced to the aircraft, which is really the key obstacle to the creation of a hydrogen-powered aircraft. Just a first note about hydrogen. We do believe that hydrogen is, particularly in the 40 to 60 passenger market segment, the best fuel source for those size of aircraft. It gives you the right payload range capability. It is a true zero solution. It is not an offset solution, and it will by 2025 give us economics that are comparable to today's aircraft. Batteries absolutely will have a place, particularly in lower payload range and payload range capabilities, and it does give you a true zero solution. And sustainable aviation fuels will have a place as well too, because of the range capabilities that it gives us, but it is at best an offset solution, and certainly at this point is also very expensive. So we do believe that hydrogen is the best solution for the types of products that we are looking at. One of the key technologies that we are working on is what we call our hydrogen capsules or hydrogen modules. This is a storage system that works both as a fuel tank in the aircraft, so these are fitted within the aircraft, but they also serve as the solution to transport hydrogen from wherever it's produced to the airport and onto the aircraft. The modules have been sized to fit within a standard shipping container, so instead of very expensive specialized equipment that you would typically need to move hydrogen around, like very expensive trucks on airport storage and tarmac pipelines, you simply need to use the modules here and the standard highly efficient intermodal transportation network to move the hydrogen to the aircraft. The capsules themselves are also extremely efficient from a weight point of view, which is very critical in any aircraft applications. They're about twice as efficient as conventional composite overwrap pressure vessels. Again, very critical within an aviation application. This is our concept of operations as to how we solve that infrastructure problem. There's no infrastructure that really materially exists to transport hydrogen today. So you simply use the modules, fill up the modules, put them in the standard shipping container, put it on a truck, put it on a train, put it on a ship, transport the modules to the airport. And then at the airport, you do not need any special ground handling equipment to maneuver the modules around the airport and onto the aircraft. And then once you land at your destination, there's a reverse logistics chain to take the modules and get them back to the filling station to refill them. So the level of infrastructure investment you need to create that hydrogen transportation infrastructure is very small compared to what you would have to do if you were to replicate today's current Jet A1 fuel infrastructure. So this is what the aircraft looks like. This is the baseline first aircraft that we are working on, which is the 50-passenger Dash 8 Series 300. It will be our first flight test aircraft, which we'll be flying next year in 2022. You can see the fuel modules, which have been loaded in the back of the aircraft through a special loading door. You hook the hydrogen in the modules up to a piping system to transport the hydrogen into the engine nacelle, where we have replaced the current turboprop engine with a hydrogen fuel cell powertrain, which consists of a fuel cell stack, which is supplied by our partner Plug Power, which produces all of the electricity, which runs the electric motors, which in this case are supplied by MagniX, which is a highly experienced partner in supplying electric motors for aviation, as well as certifying electric aircraft. And that the majority of the changes are in the engine nacelle, but it's a relatively straightforward system. We've demonstrated the powertrain architecture and configuration with a subscale demonstrator, which we have operating in Los Angeles, California. So we've proven the architecture, and we're in the process of scaling up to the 2 megawatt class over the next year. So what that gives you in terms of range and payload capability in the passenger configuration, we do have 2 versions of the hydrogen modules, high pressure gaseous, which gives you 400 nautical miles, and a liquid hydrogen module, which gives you 550 nautical miles. There is a payload reduction or passenger reduction down from 50 to 241. But because of where we believe the economics of the powertrain and hydrogen will be by 2025, we fully expect the per seat economics of this aircraft to be exactly the same as you have with the Jet A1 powered aircraft today. So that's the passenger version. And of course, today we're talking about cargo, and we do have a cargo configuration in the ATR-72. It's in essence exactly the same architecture with the fuel modules loaded in the back of the aircraft, hydrogen fuel cell powertrain, and in this case we're carrying cargo instead of passengers. We do think this is a highly interesting market. The ATR-72 has done very well in the cargo market, and we can provide a true zero carbon solution to that particular segment. Thank you.
Well, thank you very much, Rod. I note one thing, no infrastructure change needed. I mean, the airports are just going to love that. We'll get back to that later. Many thanks, and now is the time to welcome Brian and ask him to address the webinar. Brian, the floor is yours.
Thank you very much, Phil. Appreciate it. Go ahead and share my screen here. All right.
Yes, working.
Please let me know when you can see it. Is it up, Philip?
Yes, I can see it, so everybody can see it.
Perfect. Sounds good. So just a quick glance in terms of who we are as a company. So headquartered in Slovenia, our largest manufacturing plant is in Gorica, Italy. We're about 90 miles east of Venice, just to orient everyone from a geographic standpoint. So about 300 employees today, currently manufacture about 300 aircraft per year. We've sold our aircraft in over 97 countries, 12 different aircraft models. And one of the things we'd like to mention as well is that we've been profitable and have had positive year-over-year growth every year since inception, which was 1989. Moving on to the next slide, and just to lay the foundation in terms of where we're at today, I think it's best to go back to where we started from, at least from an electrification standpoint. So our contribution to electric flight started back in 2007 with the Taurus Electro, where we were the first in the world to design, develop, and manufacture an all-electric aircraft, which was the Taurus Electro. Now, while this was done under a special category of airworthiness, you can see as you scroll to the right, we've made quite a bit of progress over the past 15 years. So what's shown on the screen, there are a variety of aircraft, some that are powered by 100% batteries, some that utilize a hybrid electric architecture, and then some that are even powered by hydrogen fuel cells. Several aircraft that we'd like to point out, there's the What's Up aircraft shown in 2014. This is the first aircraft that had range in minutes at the recommended cruise speed that was greater than the time it took to recharge the battery once the battery got down to about 20% state of charge. Another aircraft that we'd like to point out is the EU Project Hipster aircraft. It utilized the serial hybrid electric powertrain, flew every day during the Paris Air Show in 2015. And quite a bit of learnings that came from that. And then moving on to the right, I'd say our most notable accomplishment to date would be the Velis Electro, which is the first and only all-electric aircraft in the world to receive a type certificate. And then shown just to the left of that would be the first all-electric inverter to receive a type certificate as well. If you look to the right, you'll see some of our next generation projects, which really leverage, let's say, all the progress that we've made to date, as well as the foundation that we've laid. So starting in the bottom right, you have the new family of cargo aircraft. There are two different iterations there. There's the V20 shown in the bottom left as payload capacity up to 30 kilograms. And then you'll have the Nuva V300 that's shown in the upper right, which we'll speak to in just a little bit more here in a second. And then in the right middle part of the page, you'll see it's our passenger transport eVTOL concept. We were one of the first the first 4 OEMs to partner up with Uber as a part of the Uber Elevate initiative. Obviously, that has since been sold to Joby, but it is a concept that we're still advancing and that we still plan to come to market with. And then shown in the upper right-hand side of the page is a 19-seat zero-emission mini liner powered by hydrogen fuel cells. So quite a few next-generation projects that are currently under development at Pipistrel today. Moving on to the next slide, and given that the focus of discussion today is really on logistics and cargo transport, what I've shown on the page are 3 different logistics-based applications that are either currently flying today or under development. So to start on the left-hand side with the Nuva Sherpa, this is an aircraft that is currently in commercial operation with Wings for Aid, who's a humanitarian organization out of the Netherlands. So this organization has received SORA approval in Germany, as well as numerous countries in Africa. They're currently flying the aircraft in 3 different countries in Africa. If you look at the image shown, you can fit about 400 kilograms worth of payload in the aircraft, about 100 kilograms under each one of the wings, and then 200 kilograms within the fuselage of the aircraft. So this aircraft is being operated on a 100% unmanned basis today. As you can see from the image as well, one of the other benefits of this aircraft is that the pods are droppable, and so it allows for more operational flexibility, and thus eliminates the need, at least for a certain part of your operations, to have a runway. Now with CTOL comes typically lower DOC, and so when you look at the cost per metric ton per nautical mile, you'll see €1.75 there. Now, when you scroll to the right, you'll see the 2 different hybrid electric cargo transport vehicles that are currently under development at Pipistrel. So there's the Nuva V20, which has payload capacity of about 30 kilograms, max range of about 300 kilometers. And if we were to outfit that with a 100% battery electric architecture, you would lessen your range to about 100 kilometers in that scenario. As you scroll to the right, you'll then see the Nuva V300, which has payload capacity up to 460 kilograms. Max range at 100% payload capacity would be about 500 kilograms. And the end markets that we really see for both of the VTOL applications, it's everything from medical to mining to oil and gas, ship to ship, ship to shore, as well as both small and heavy cargo logistics. In terms of where we're at today and the progress that we've made to date, so for the Nuva V300, we've completed subscale prototype testing of 2 different subscale prototypes. We have 2 full-scale prototypes that are currently under production at this point that will begin flying in airspace that we've carved out in Slovenia in March to April of next year. By August of next year, we'll have 5 full-scale prototypes flying, and we will ship those to SF Express towards the end of next year, which will then commence commercial operations within their network in early 2023. Now, I think the last thing to point out here is that if you look at the cost per metric ton per nautical mile, and I hit on this earlier, one of the things you'll see is the difference in DOC when you go from a CTOL application, i.e. the Sherpa, then going to a, let's say, a low payload capacity drone like the Nuva V20, and then going to, let's say, a heavy logistics VTOL application like the Nuva V300. So there is one, let's say, a price discrepancy or a DOC discrepancy when you move from CTOL to VTOL. And then 2, you also noticed as you scale up the cargo capacity of the vehicle, your DOC drops accordingly as well. So what that really calls for is, hey, in order to make something like the V20 and the V300 work, you need to make it work on routes in which you either don't have access to a runway, routes that are difficult to serve, let's say, by alternative vehicles today, whether it's sea vessels, it's ground vehicles, more rural parts of the world, things of that nature. So that's really it for me today. Happy to take questions after that, but it's a quick overview of who we are, what we've done in the world of hybrid electric and electric flight over the past 15 years, and then what we're doing from a logistics and a cargo transport perspective at this point in time.
Well, thank you very much, Brian. And again, thank you very much also for the two previous panelists. I mean, what strikes me here is that we're really talking about game changers in environmental terms, economical terms, and operational terms. I think at this point in time, I'd like to kick off the Q&A. We have received, I'm saying this for the audience, we have received a number of questions through the chat. We will get back to them. What I would like to do is perhaps kick off by getting back to the wider framework. ASL, I think we'd all be very interested if you could elaborate briefly on the makeup of ASL's Cargo Vision Forum, which you mentioned, and perhaps dwelling a little bit on the current initiatives that are in place or that you have with regard to the sustainable freighter and cargo operation.
Certainly, Philippe. First of all, I think just the makeup of the ASL Cargo Vision and Forum is really carved up into 4 sections. And if we look at them, the first one is propulsion. Obviously, that's the thing we're talking about in terms of the ATR, as you saw earlier with Rod's presentation. Hydrogen, there's a lot of discussion also regarding electric. If you look at some of the members of the forum, and I'm not going to go into the specifics now, but their focus is electrical. And I think Brian mentioned it as well, and Rod did. A lot of the derivative electric applications in terms of what they're doing comes from people within the Cargo Vision Forum. So propulsion, first off. Secondly, drones. And some of the names there are very clear, like Drone Dynamics in Europe. There's Drone DDC in Canada, and so on. And then we have Flylogix, who we heard from a few months ago as well. So drones, again, very important aspect to very specific niches in terms of satisfying probably the smaller composites in terms of cargo transportation. The next issue is semi-autonomous or autonomous flying aircraft operations. And this is something that is really being focused on by a number of the people around our forum, and probably the leadership in terms of that is Reliable Robotics, where they've made a lot of headway with the Cessna 208 Caravan. And I think the technology, as most of the guys will agree, is almost ready for it. And if we think about it, cargo, I think would fly without pilots long before people want to get in an airplane and go from A to B without a pilot. And somebody reminded me recently, you know, your grandmothers, my grandmothers, if you'd said you're going to get on a train that hasn't got a train driver, they would have freaked out. And look what's happening today. And I think fourthly, important to say in terms of Cargo Vision, the new technology aircraft that are being developed. And there too, you know, I think very, very capably, Brian touched on it there. Some of the applications they've got in fitting different niches and very successfully referred to SF Cargo in China, their take-up. You know, you've seen the Alice aircraft from aviation, also very taken up by DHL and so forth. There's a lot happening. So the drive really, as I said in my intro, is really to create the awareness and promote the initiatives amongst the group. And we'll see more about that shortly. If we look at current initiatives very briefly in ASL, on the 737 fleet, as I mentioned, it's pretty core to our operations. The classic fleet is exiting on a planned basis to be substituted with the 800 new generation freighters. Classic ATR 72 also being replaced, has already been replaced with the 600 freighter, brand new freighter, ex-factory. We've been the first to fly those airplanes in anger in terms of cargo. And then most importantly, we've got to say, and we touched lightly on it, but sustainable alternative aviation fuels is a big issue, and we've already flown a number of aircraft on SAF already. So that's also very much in the focus going forward. And I think we also deal with issues in the day-to-day operation where we look at, fuel saving initiatives are taking on a different profile, obviously with SAFs and so on. So things like complementing it with single engine taxi, optimizing fuel uplift quantities, and then even ground handling support, which comes outside of the aircraft operations, where customers and providers are using electric vehicles and ground support equipment to load aircraft and offload aircraft.
Well, yes, thank you very much for that. I mean, what's fascinating is that you really cover the whole scope of non-fossil fuels, as I understand, and that actually it leads me to a question that I would like to put to Rod now. You mentioned, and I said with some humor, that airports will love you because there won't be any need for major modifications to the infrastructure. I come from an airports background, and I've done a lot of operational safety on the ground, including ground handling. I'd be very interested if you could elaborate a little bit on the way those new aircraft, I mean, the aircraft is not new, but new propulsion system will be handled with on the ground. So basically, I guess my question is, do you expect hydrogen cells powered aircraft to be handled the same way, or with which differences? And in addition to that, do you expect them to be handled or operated as competitive, in a same competitive way as kerosene or Jet A1 powered aircraft? You touched upon it, but if you could elaborate a little bit, I think the audience would appreciate.
Yes, certainly. We've spent considerable time looking at and designing the infrastructure solution to take into account the airport and ground handling aspects of that, going back to the initial founding of the company, because we recognized that was going to be very important. So, as I mentioned, we've in essence designed the system and designed the modules to be handled as dry goods or as any other regular cargo. So you can you load it onto the aircraft, onto a roller ball mat, move them forward, latch them down. You can use regular forklifts, regular scissor lifts to get them onto the aircraft, and similarly to maneuver them around the airport. So we've spent considerable time designing the system to utilize equipment that already exists, and that obviously is to minimize the capital required to create the infrastructure that's required to deliver the hydrogen to the aircraft. As far as the economics are concerned, again, we expect that by 2025 that we'll see equivalent per seat or per freight ton kilometer economics comparing a Jet A1 powered aircraft to a hydrogen powered aircraft for two fundamental reasons. First of all, we expect the cost of green hydrogen to come down very rapidly over the next 5 to 10 years and to keep on going as the efficiencies and the costs of electrolyzer equipment plummets, as the cost of green hydrogen plummets. We've already seen many people start to announce new electrolyzer and green hydrogen facilities. So we're already starting to see the new production capacity come online. And the second reason is the maintenance costs on the hydrogen fuel cell powertrain. We expect to be less than what you would see on a turboprop engine. A turboprop engine today, when it comes to overhaul costs, as many airlines who might happen to be on the call today will appreciate, are extremely expensive. And in the hydrogen fuel cell powertrain, we're talking about an electric motor, which is really a very straightforward design, operating in a very benign temperature environment. And the fuel cells themselves essentially have no moving parts. So there are parts that do need to be replaced or maintained, but overall we expect the cost of the hydrogen fuel cell powertrain to be less than today's turboprop engines.
All right, that's really interesting and really reassuring for the future. Now I'll dwell a little bit on the economical aspects with Brian. When we were preparing this, we looked also into the facts and fictions of cost and performance, and it's somehow the evolution of the question I've just put too broad. But it would be very interested to hear your version. Your technology obviously isn't the same, although electricity is involved. But it'd be very interesting to hear from your side what would be, or according to you, the facts and fictions of cost and performance claims being made by the industry. And perhaps what could be also interesting to hear from you are your views on the current regulatory environment. I think the three panelists touched upon it very briefly. Certification is the key word. You can't just have things flying without being certified. We all know this. So beyond the facts and figures, the economics, I'd like to talk a little bit about certification. Brian, what would be your view on these things?
Yeah, great questions, Philip. So let me start with your first question. So in terms of what we've seen in the industry, which, let's face it, there have been all sorts of both commercial and technical claims that have been made in terms of what we can get DOC down to, in terms of what we can do for both an all-electric as well as a hybrid electric VTOL aircraft in regards to range, payload capacity, as well as other technical characteristics. And so what I showed just 5 to 10 minutes ago is what we believe is essentially what's based on reality today, right? So due to the fact that Pipistrel has been in business for 32 years, we don't make unfounded performance and technical claims. What we do commit to, we 100% believe that we will deliver and deliver on time. Now, to get further into your question in regards to cost, so in the second row of the last slide that I just presented 5 to 10 minutes ago, what I showed was a metric that was defined as a cost per metric ton per nautical mile. And for something like the Nuva B300, I was at €2.76. Now, if I compare that to the next best alternative, so let's say a diesel truck as it exists today, you'll be closer to €1.20 per metric ton per nautical mile. And then if you compare that to a sea vessel, you'll actually get all the way down to about 71 cents per metric ton per nautical mile, which tells us, if we're being realistic, that the only way for something like the V300 to work is if we're doing it in areas, let's say, that are either underserved by existing ground infrastructure, areas in which, in order to access, you have to drive around a windy road, drive around a mountain, something like that, right? To where if you then equate air miles to ground miles, the €2.76 actually ends up being more competitive than the €1.20 that I just gave you. So to us, right, it's important that we're realistic and we're self-aware in terms of where this vehicle has a place, as opposed to projecting, or let's say touting the belief that this vehicle will end up blackening the skies and we'll have 10,000, 20,000, 50,000, 100,000 of these flying by 2030, 2035, 2040. Now, to get to your second question in terms of the regulatory environment, our thoughts there is that from a technology standpoint, we are almost there, right? So starting with the propulsion system, from a hybrid electric and electric standpoint, we've plowed quite a bit of ground as an industry over the past 15 years. Even within our portfolio today, and this gets to unmanned flight, today we have 150 unmanned surveyors that are flying all over the world. So we've sold 32 to those to SOCOM, who's flying them 5,000 plus hours a year each, primarily along the southern border. We've sold 30 to the U.S. Air Force, who's primarily flying those in the Middle East today, once again on a 100% unmanned basis. Now, there are other parts of the vehicle that I can get into, but I feel like today a lot of the questions in the industry are focused on, let's say, the propulsion architecture as well as unmanned flight, whether that's based on automatic flight, it's based on autonomy, so on and so forth. From our standpoint, the hurdles that we still have to overcome are really on the regulatory side, whether it's in regards to airspace management, it's in regards to UTM. So right now, and even Hugh pointed it out earlier, right, there are folks like Reliable Robotics, of course, who's another Cargo Vision member, right? That's focused on advancing detect and avoid functionality, in implementing that into aircraft as they exist today, right? So to us, those are the things that we need to further look at and to further advance as an industry from a technology standpoint, along with tackling the regulatory environment in order to see these vehicles actually advance, materialize, and get deployed into commercial operation at a reasonable time. Now, the last thing I'll say, and I think everyone knows this, there are certain parts of the world from a regulatory standpoint that are just more friendly at this point. China is one of them. Europe is definitely more friendly than the US. I'd say certain parts of Africa are definitely more friendly as well. Once again, from a regulatory standpoint. And then, excuse me, when we also couple that, let's say, with other factors in terms of customer acceptance and other hurdles that exist in the industry, there are definitely, like I said, certain parts of the world to where we see this technology being deployed first, as opposed to other areas, let me say.
Well, that was crystal clear. Thank you very much. On the issue of certification, Rod, is there anything that you would like to add in particular?
I think just that the process itself is, I think, very well known. Obviously, we are dealing with some new features that need to be certified. But the process of dealing with new and novel features like that, if you're looking at the FAA, Transport Canada, or EASA, are very well known. So I think it's simply a matter of executing the process and developing the technology and doing risk reduction testing, which is exactly what we're doing over the next 10 to 12 months. And if we follow that path, we believe we'll hit our target of 2025 service entry.
All right, thank you very much for that. I think at this point it'd be interesting to turn towards the questions that were put to us put to you by some of the audience today. There is one that really struck me, and pardon my ignorance, but we've got a question here that basically goes: can the aircraft powered by hydrogen modules take off and land without using fuel on top? I wasn't under the impression that you use any fuel on top.
No, the question's not perfectly clear to me, but I'll explain it like this, which is the aircraft itself will be purely hydrogen powered. As you saw in the pictorial of the aircraft and the conversion that we're working on, the hydrogen fuel modules are loaded in a compartment in the back of the aircraft, which we do take out some seats to create the space for the hydrogen modules. But beyond that, the hydrogen serves as a fuel source into the fuel cells to be converted into electricity to run the electric motor. And other than that, we're designing the aircraft to have exactly the same performance capabilities and parameters that the aircraft does today. So same takeoff field length, same climb capability, same single engine ceiling, and so on.
Right, and I would then suppose that you would apply the same operational envelopes, the same flight levels to be reached. You would basically fly one of these aircraft like you would fly a regular aircraft of these days. No need to modify the SIDS, the stars, no need to modify anything in terms of operational safety. I'm thinking about my colleagues controllers, for instance. No need for additional separation, whatever. I'm sure you've been through that, but basically your answer is those planes will be flown and controlled and separated and operated on the ground like any other aircraft.
Exactly right. We've in essence designed the powertrain itself to give us the performance levels that the aircraft does today, and on all the parameters that you would have, whether it was climb capability, descent capability, cruise speed, takeoff and landing field performance. We've designed the powertrain to back into give us exactly the performance levels that the aircraft have today.
And I guess the same question could be put to Brian, but I can anticipate the answer because I see you nodding, Brian. We had a question here also: which speed can be maintained by aircraft alimented by electricity? So basically, what Pipistrel is proposing. What about the operational envelopes of your planes?
Yeah, no, absolutely. Good point. So in terms of operation envelopes, let me get to the V300 first. So we've essentially sized the vehicle to do a takeoff at roughly 10 to 12,000 AGL with 2 rotors out, and then with the de-icing system, because the vehicle is an all-weather operation vehicle, you can essentially get about 300 or you can carry about 350 kilograms worth of payload, traveling about 500 kilometers. Now, if you take the de-icing system out, that's where you get closer to the 450 kilograms worth of payload capacity that I had on the slide that I presented. And then, sorry, the second part of your question was, Philip, one more time.
Sorry, now you got me because I had it on the screen. It's gone now. No, it was basically the whole operation of the aircraft. I mean, we spoke about operation on the ground, takeoff and landing, but it's also about the performance of electrical driven airplanes from a controller point of view, separation, safety, operational safety. Nothing would be affected by the fact that an aircraft would be powered by electric engines, would it?
Correct. No, and we actually believe that that all electric aircraft will actually be so on top of having lower DOC, emitting, let's say, a lower noise footprint, lower carbon emissions. They're actually safer as well. So if you look at today, let's say in the general aviation industry, right, the main causes of fatalities, as well as catastrophic damage, there are certain things actually that hybrid electric and electric propulsion bring to the picture in terms of safety, which is not typically the first reaction, let's say, that most in the industry think or have when they think of an all electric aircraft, but there actually are quite a few benefits. And if I had more time, I'd love to go into that in detail, but I want to make sure that I reserve time for the rest of the questions and other topics that need to be addressed.
Well, we thank you very much for that. It's a nice thought, but we're nearing slowly but surely the close up of the webinar. We actually got something like 7 minutes to go, and with that in mind, I think what we've just been discussing right now and the elements that you have brought to the debate, both Brian and Rod, brings me to asking a question to you. From an ASL viewpoint, a cargo vision viewpoint, what would be your ideal timeline of, I wouldn't go as far as saying replacing conventional aircraft with either electric or hydrogen. And again, like I said, there is a convergence anyway. But in general terms, what would be your ideal timeline, including the solving of all the regulatory issues?
Philippe, I think one's got to, first of all, before you get to the regulatory side, also work with the market, with our customers, to see what their requirements are,
Obviously,
so that we don't go off on a tangent. But that said, I think I said earlier, we are very much doing things rather than just talking about doing things. And in that regard, we signed an LOI. I think a number of people who might be watching the webinar may have seen it, between Rod's company and ASL regarding the conversion of power plants on the ATR 72 freighter to hydrogen propulsion. So we're very excited about this. The announcement, as I say, was made this week. And perhaps on the technical side of that, I might just pass the ball, if I may, through yourself to Rod. Rod, if you want to just add to that in terms of more of the details as you see timing and regulatory issues.
please.
Yeah, thank you, Hugh. We're very happy and pleased to have signed this LOI with ASL for a number of reasons. First of all, I think you and ASL need to be commended for all of the work that they're doing to support the development of these new technologies to create zero carbon solutions. But the LOI calls for up to 10 conversion kits for an ATR 72 cargo configuration to be converted to hydrogen fuel cell powertrain. And While our flight test aircraft is the Dash 8 Series 300, we expect the ATR 72 program to follow very rapidly after that. So we're still targeting service entry for an ATR 72 configuration by 2025 as well too. And just to add one more point on the news front, which we think is important and shows the support for the development of these types of technologies. We also announced just this morning the closing of a new funding round for universal hydrogen of $62 million. So that will help very much to progress our development activities, particularly over the next 12 to 18 months.
Well, thank you for those announcements. I mean, that's really thrilling and fascinating, and it really means, I mean, it proves that the whole industry is moving forward, and maybe that's going to be the occasion for the last question before we go towards the end of the webinar. But there is one question that's just been put to us through the system that actually hooks onto what you just said. It's interesting, talking about timeline and the future. Do you think there is a possibility to one day see either hydrogen or fully electrical powered cargo planes the size of a 747 with the same range of service, the same operational characteristics? I mean, we don't know whether the market will require it or not, and thank you very much for reminding of it. But hypothetically, will we be seeing one day a 747 flying without kerosene? Any of you can answer.
Well, I think maybe from the ASL point of view, we obviously would aspire to something like that, very much so. What exactly that's going to mean, I think, is exactly what we're busy with at the moment. You know, if we take the initiative here with the universal hydrogen conversion, it's a bridge towards the future. It doesn't mean that Rod's going to look at hydrogenizing 747s. I think 747s de facto might be very expensive airplanes by virtue of 4 engines to continue operating 10, 20 years into the future. So it's a different discussion, but I think it's way off in terms of something new like that. I think the OEMs like Airbus, Boeing have made statements regarding hydrogen, but again, the economics of flying a cargo airplane, which does a lot less utilization in a month than does a passenger airplane, will have to be taken into account.
But if I may, that's interesting. Oh, sorry, go on, please.
Sorry, if I may add, Philippe, just I'll say absolutely, we certainly see a place for hydrogen in the larger aircraft segment, although it's very likely that it'll have to be a clean sheet design to allow hydrogen to be deployed into to larger aircraft like that. I don't think that a retrofit market will really develop for aircraft like that, but clean sheet designs that have hydrogen as a fuel source, absolutely.
Any view from Pipistrel, Brian? You plan to do a monster?
So we'd never say never. Now, the reason we're starting obviously with the 19-seater is that's close to, at least from a liquid hydrogen towards the end of the decade. Not to say that there isn't other potential for alternative propulsion architectures, as well as potential beyond that. But at this point, we really see 19-seat being close to the limit of where it makes sense towards the end of the decade.
Yeah, that's very clear. I think the last point that I really want to put to you, and maybe you can comment on. We've been all very positive, forward-looking, and I'm personally very amazed by the technological advance. I think it would be wrong to leave the audience or to close the webinar without pointing at the possible showstoppers. What could actually make the evolution towards a non-fossil fuel cargo aviation. I think if you could very, very briefly, starting with Brian, tell us a little bit about that. What could be the showstopper?
Honestly, in our view, the biggest showstopper at this point will be the regulatory framework. As I mentioned earlier, right, there are certain civil aviation authorities and other regulatory bodies that have definitely been more friendly, that are leaning forward more, right, and that are more willing, let's say, than others to embrace more cleaner forms of technology, more specifically relating to aviation. And so from our standpoint, it's not necessarily technology that will hold us back. Obviously, as we try to scale it up into, you know, larger and larger aircraft, trying to carry more payload and trying to travel further and further, right, we'll definitely run into limitations there. But where we stand right now, especially for the projects that are currently under development at Pipistrel, we believe the technology is there. It's more about now working with the regulatory framework, different civil aviation authorities, in order to ensure that we can actually deploy these vehicles and make this whole thing come together, let me say.
Yeah, that's crystal clear. Thank you very much, Brian. Rod, maybe a different viewpoint, or do you share Brian's point of view?
Fundamentally, yes. Fundamentally, we don't see any showstoppers, to use your word. There are areas where there have greater risk and greater need for work and development and funding and testing and so on. And I think Brian's hit on the top one, which is the certification path for these technologies is probably the area which needs the most work and has the most risk. But we absolutely believe that if we execute on the process, that we'll get there.
Right. Thank you very much for that. I think we can conclude now. And to tell you the truth, it's been great to hear all we heard today. It's really reassuring. Looking forward to see this part of aviation, this sector of aviation evolving and looking into the future. Now, each of you, I'll give you a little less than 1 minute. If there was a final key takeaway, a final message that you would leave the audience with, what would it be? Starting with Brian.
Yeah, well, let me give kudos to first to Rod, right, for the significant capital raise they just executed on, as well as to both ASL and Universal Hydrogen for the LOI that they just put in place as well. But you know, to leave with my final thoughts, let me say this, right? It's easy to sit there as an industry and it's easy to get distracted, right, by the 47 things that, you know, could go wrong, or by some of the hurdles and some of the potential, you know, showstoppers, right, that will potentially prevent us as an industry from moving all of this forward. I think what we need to continue to do as an industry, though, is that we need to continue to work together. We need to join forces, and we really need to propel all of these efforts forward. And that's one of the reasons why I'm a huge fan of what ASL has done with the Cargo Vision Initiative. I mean, obviously, no one who's dialed in today, right, takes place in our, or let me say participates, right, in our frequent calls, but it's a very collaborative effort, right? We're working together. We're trying to advance things in the industry, and that's really what we need to see in order to move things forward.
Thanks, Brian. Rod, one strong message, keyword you would like to leave our audience with?
Yeah, thank you. Thanks again, Philippe. To me, it's pretty straightforward, which is aviation has always, I think, believed that it would be a massive challenge to try and meet Paris 2050 Accords, for example. And I think quite openly, I think the industry has always looked for excuses for finding ways to not have to meet that. And what I've come to learn, and I would impress this upon everyone, is that there absolutely are solutions out there to get us to Paris 2050 Accords, and they're achievable. The time frame is achievable. We just have to commit to executing on all of these technologies and developments.
Awesome, encouraging. The last bullet is for you to fire.
Yeah, just to add and confirm what the guys have said, but I think two important things. One, confirming the need for us to work together as an industry to get to this problem. And that's the second point, is exactly that. The problem of global warming, carbon emissions, call it whatever you like. We were at a Boeing innovation conference last week, and what came out there is this global warming is a far bigger threat to us on Earth than is the risk of COVID. And it should be put on a war level for us to focus on dealing with very, very quickly. And I think it traces back to regulatory issues too. We have all got to work together with our regulators to make sure that we get to an end very, very quickly in terms of resolving these issues. Thanks.
Thank you, Hugh. Indeed, you're right. I really want to thank you wholeheartedly, especially those who had to wake up very early on their side of the pond. Thank you, Rod, Bran, and Hugh. And to the audience, stay tuned for our next strategic webinar on the evolution of the European air navigation charges model that will be aired on 18th of October, 1920. Thank you very much.